Hey everybody, it's Pete A. Turner, executive producer and host of the Break It Down Show. Megan Konar joins us. She's a civil and environmental engineer, professor, researcher from the University of Illinois at Urbana-Champaign, Illinois. And what she does is she looks at how food and water move and flow and are used as a resource in the nation. So when we think about things like global warming, like how, okay, we want to get trucks off the road to not move food. But then she's like, yeah, but trucks are really resilient and there's always a road adjacent if a road washes out. We move a lot of food on the Mississippi, but those locks have to be maintained to maintain that. And you need that redundancy and all these things, this push-pull. And by the way, California has all of this food moving around internally, externally. It really feeds the nation and feeds itself as the biggest state in terms of population. So how do you create resiliency, but also efficiency there? And there's business efficiency they're concerned with, but also environmental impacts. So as you study all these things, you just have more and more questions, and it's just a fascinating show. You're going to be able to look up a bunch of her articles. She was noteworthy a couple weeks back when her latest article that kind of shows a matrix of how food moves around the nation, and that's the image for the episode. You probably saw that story in the news because everybody was really fascinated by it. It's such a great graphic. So take a look at Megan's information on, well, Wikipedia and everywhere else, and you get an idea of just what she does. Fascinating conversation. Hey, if you're new to the show, we do things like this. We have PhDs on, and they come and they talk about what they're doing, and it blows our mind. Like Andrew Friedman, who talks about cosmology. Sometimes we talk about cosmology and religion. We also have athletes on the show. We've had Tito Ortiz, who's a UFC Hall of Famer, and also a wrestling Hall of Famer from his wrestling days. But then the next day, we might have someone totally different on. Recently, we had David Daniels on. He's a flight nurse who's everybody talks about, who knows him as like the best nurse they've ever met in their life. And this guy is tip of the spear nursing guy. So a lot of different things to fill your ears for an hour every day. 5 days a week, that's the Break It Down Show. If you love the show already, just can keep doing what you're doing. Share the show, buy the shirts, tell people about it, suggest the show. Those are the things that really help us. It really, really helps when you subscribe, truly. I'm going to stop putting the show up on Facebook as much. It just takes too much time. That's why I really need you guys to subscribe. That way I can do other things, work on news stories and work on other stuff instead of always social mediating. Hey, one last thing. Save the Brave. SaveTheBrave.org. If you go there and you click on the monthly donation tab and put a small amount of money each month in, we will then go and take that money and put it to work. We're already getting veterans in at Lakers games, at comedy shows with Jay Moore and Chad Prather. We're already taking them deep sea fishing, and this builds this community around these guys. It gets them invested in their own life again, and it gives them purpose over time. It really works. We are truly helping people, and we could use your help in helping them. Here comes Megan Konar.
Lions Rock Productions.
This is Jay Moore.
This is Greg Proops.
This is Jordan Harbinger.
This is Dexter from The Offspring.
This is Nathan
This is
East.
Sebastian Younger.
This is Rick Marotta.
This is Stuart Copeland.
This is Mick Gillette.
This is Andy Summers.
Hi, this is Skunk Baxter.
This is Gabby Reese.
This is Rob Bell.
Hey, this is John Leon Guerrero.
Hey, and this is Pete A. Turner.
Hey, this is Megan Konar, and you're listening to the Break It Down Show.
Megan is, she authored a paper that a bunch of my friends and I saw. You know, we're a military crowd, and so your work goes right to our military mind, you know, especially this most recent paper when you looked at the flow of food in variety of forms, whether it's milk or yogurt or grain or whatever it is, and how it gets into where it gets to and where it goes out of, because that stuff's fascinating. But you also have an interesting background in that you're sort of an engineer, though you work in the civil engineering field. I mean, certainly this paper talks about that. Just give us an idea about your background so we can kind of get rooted here.
Mm-hmm. Sure, yeah. So I'm in a civil and environmental engineering department, but my research is interdisciplinary.
Okay.
And so I'm interested in, I'm interested in water resources.
Right.
But through water resources, I've gotten more interested in agriculture and food systems because most of our water goes to growing crops, which in turn then go into food supply chains. So I've just gotten increasingly interested in how this water is incorporated into agriculture and then underpins our food supply chains. And I'm interested in, do food supply chains lead us to use more or less water? What are the water hazards that threaten food supply chains? Water hazards could be kind of short-term things like droughts and floods, or they could be long-term threats like unsustainable groundwater use that will require that we grow crops in different ways in the future once the groundwater runs out.
Right. Okay. What are your degrees in, so we can get an idea of what your background is? Because I'm going to figure out, like, how on earth, like, when you're sitting there, senior year at whatever, Shermer High School, and you're like, you know what I'm going to be? You don't ever think of someone who is a sort of civil engineer who looks at the flow of water and supplies, and that's not something anybody picks. We would never know it was anything, you know? So
Yeah,
how did you get to that point?
It is unique, and it's been a long and circuitous route, that's for sure. But I started off at UC Berkeley and did environmental science policy and management at UC Berkeley. So, and there I grew up in the Chicago suburbs. And so moving to UC Berkeley was a really eye-opening experience because I realized that water is actually the scarce and valuable resource that I had taken for granted when I was living in Chicago, because we have plentiful fresh water living near Lake Michigan. And then when I moved to Northern California, you realize that California has a lot of really complex water issues and politics, and the south of the state has much less water resources than the north, and so that just really got me interested in water resources.
Right. And then follow on after Berkeley, where did you go?
Yeah, so in Berkeley, I actually took some time off and traveled for a while.
Good for you.
So I backpacked for a little bit, which was an amazing experience, and highly recommend that more Americans do it. A lot of Europeans, other people in other countries do that.
Quit being in such a hurry, right? Like, go live a little.
It's a great time to see some of the world. Then I worked in Chicago for the U.S. Army Corps of Engineers and got some experience managing freshwater resources around Chicago.
Did water find you, or did you find water?
I think, thinking back, I was always around freshwater, and I was interested in freshwater when I was a kid. I remember I must have been about 10, and there was the Great Chicago Flood, or I would have been 12 because I think it was in 1992. But there was the Great Chicago Flood, and I remember that really was interesting to me, and I was fascinated to see the city come to a complete standstill when the downtown area flooded. So I think I've always loved going to Lake Michigan, and always loved kind of being outdoors. So maybe it was a bit natural, but then I've gotten more interested in kind of the technical aspects of water, the engineering and the economic components of water resources along the way.
And what about your post BA or BS stuff? Where did you go for that?
Yeah, and I did a master's in England at the University of Oxford.
Fancy.
And then very fancy. And then I came back to the U.S. and did a PhD at Princeton.
At Princeton, because you're no slouch. Yes. Yeah, that's fantastic. Thanks. What was your PhD in?
That was in civil and environmental engineering.
So you have an engineer education, but you are a multidisciplinarian.
That's right.
It's interesting. Okay, so looking at how we move food, here in California, we've got two land bridges, the 80 and the 10, that go straight across, and they push a lot of supplies everywhere. And we grow many millions of boatloads of food in the Central Valley and then along the coast. It makes us basically the bread basket, the fruit and vegetable basket for the nation. In the paper, you talked about like the counties that move the most, and it was like California County, all these California counties, and even in this case, Maricopa is so close to California, it almost in effect is part of the same system, or is that not fair?
Yeah, I mean, and so part of it is, so in the study we did find that a lot of food, the California counties are the biggest movers of food, and that's a lot of reasons. It's because the Central Valley is so productive in terms of fruits and vegetables, also grains. It's because California has major urban centers also, so raw agricultural products are going there and being either processed into more processed goods, or they're going just to direct consumption, or there's a lot of international harbors, so there's food either coming in from other countries then being moved around the country from California, or it's leaving the country and being exported out of the harbors. So that's part of the reason. Also, it's a bit mechanical as well, just because western counties are so much bigger than eastern counties.
Right.
So we were trying to figure out information at a more coarse scale. We were trying to estimate county scale flows. And so just the fact that there's so many fewer counties in the West and the counties are so much bigger, that also has a bit to do with it.
And I was fascinated by some of the things you talked about in the paper with you and your team, like the processing of the food. So here comes the milk. The milk goes to the plant. It gets turned into yogurt and then primarily pushed out locally. and we always talk like farm to market kind of thing. Is that the preferred way when you look at how things work, or are these big international movements of food a better way to do it?
Yeah, and that's, in this study, we don't really have any normative assessment of what's good or bad, but we are increasingly interested in looking to try to understand, because we would hypothesize that food supply chains are organized to be as efficient as possible, typically. So they're probably trying to be efficient in terms of at least cost, trying to get the most affordable product to the consumer. But we're also then interested in figuring out, does that focus on efficiency come at a trade-off with being resilient? So does that mean that our food supply chains are vulnerable to disturbance, or can you have both efficiency and resiliency being optimized? So that's something we want to look into.
And is our system fairly resilient? I mean, I know like you talk about the Mississippi and Ohio rivers, now they're big transport highways, but in effect, we could put trucks out to do things on that, or is that just not at all the case?
Yeah, so I think we haven't finished this work, but I think we'll find that there is a pretty decent trade-off between efficiency and resiliency. Just the fact that we do have multiple modes that we can move food around. So things like grain or these very bulky commodities, which are pretty cheap commodities, that's where it's a little bit more tricky, because it's very cost effective to move those grains out of the Corn Belt on barge down to the Port of Mississippi. It's I think would be cost prohibitive to move that much grain on trucks or on rail. So that's why the barge is really important. And if you were to have failure along some of those locks, that might be problematic for moving grain out of the Corn Belt. I didn't realize how many truckloads of grain fits on one barge.
Yeah.
One barge is equivalent to 1,000 trucks.
Wow.
So I had no idea how big these barges are, but they move a big amount of mass.
That is crazy.
Yeah.
And does it have to be a river the size of the Mississippi to move that much stuff, or like the Missouri? There's so many rivers. Like, do they all have, obviously not smaller rivers, but like those big ones, do they all have that capability of having big barges like that? Or
yeah, I'm not sure at what point they're too small. I think Missouri has some of the big barges. I'm not sure exactly where it gets to be too small for that, but definitely up and down the Mississippi.
But these are likely, in terms of the U.S. ancient systems too, right? Like, as long as people have lived along the Missouri, they've lived there because you could put a hunk of wood in the water and float it somewhere, or oar it somewhere up, and take a cow to market or whatever it was. Yeah,
Mark Twain, a lot of his writing is based on barge and shipping life along the Mississippi.
You mentioned those locks on the Mississippi River in your paper, and just now a minute ago, I'm talking about how they're a choke point, and these locks are almost 100 years old now. How long do locks last? I mean, we talk about infrastructure all the time, like on bridges and all these things that are really old. I mean, all the projects from the 30s, all almost 100 years old, right? So some things are maintained well, like the bridges are always getting painted and looked at and everything, but the locks, I don't know. Talk to me about that. Yeah, no, it's amazing how important this infrastructure is still, and it's, getting on in years, like you mentioned. And I did find out that there has actually been a lot of work ongoing by the U.S. Army Corps of Engineers on those locks, locks 51 and 52, which are some critical locks in the Missouri area for shipping grain out of the Corn Belt. And I think in my article in The Conversation, I said they hadn't been overhauled, and some readers luckily corrected me and said that they've actually been doing some maintenance and investment. And I'm not sure what the exact current stage is, but I think they're working on getting those up to date. The civil engineering task of repairing or replacing or updating something like that, I mean, that's a significant project, because you're not doing that in 2 weeks, and you got to shut down that part of the river, I'm assuming, right? I believe there's ways to do it with minimal disruption to shipping traffic. Incredible, really. Wow. So what else was interesting that you guys pulled out? Because there's so much. Like, there's that one county in Texas right on the coast. Is that a port? Because it doesn't look like it's a port town that I know of. Do you recall?
I don't recall the one in Texas.
There's one just like right there on the Gulf, and it must be a port that food comes in there. I don't know.
Yeah, it could be overland.
Could be.
Don't remember. Yeah, I think the most interesting thing to me about this paper was just the fact that I actually thought this was one of my more boring technical papers.
Yeah.
So I've been really surprised with how much interest it's gotten from other scientists and the general public, and it really, to me, just shows the power of having a really easy to understand and pretty map. So I think just that map really caught a lot of people's attention, and it's really surprised me because I thought this was a really boring algorithm development paper that was going to enable our future work.
Yeah.
But a lot of people have actually been interested just in this paper.
Yeah. Look at all that alfalfa.
Yeah.
Huh. Look where it's going. Yeah.
And I think part of it too is, and I've just been trying to think why has this paper gotten a lot of attention, and I think it's partly just because you can see how interconnected Americans are from this map, and that's something that you hear a lot in the news, how polarized or how disconnected American society is right now. So I think maybe it's nice just having a visual representation of the fact that we actually are really all connected, rural, urban. We all need each other.
Yeah. Yeah. So you guys examined also like livestock movement too? Or okay, so even like chickens and turkeys and stuff.
That's right.
What do we need to know about that? Like, what did you guys determine?
So we haven't really determined anything other than for all food groups, we've just basically estimated them.
Okay.
So we haven't had the chance to really dig in yet and do any further analysis, but just trying to determine. So it was really just coming up with methods, and so that was we developed a whole bunch of new methods for mapping all the food groups. So we used machine learning, linear programming, and network statistics were some of the main tools that we sort of weaved together in order to estimate these food flows, and we had to come up with a different statistical equation basically for each food commodity group. And so we don't estimate for livestock, we don't estimate chicken or pigs or beef individually, because we estimate what's called the Standard Classification of Transported Goods. Okay. So that's the U.S. Commodity groupings. So we were restricted to the U.S. commodity groupings. And their groupings, there's just 7 kind of big commodity groupings for food. And one of them is for all live animals. So that would include everything like beef, pigs, chicken, hens.
Kangaroos.
Maybe.
Emus.
Maybe.
Do eggs fall into that category?
Eggs are in there. They would be in animal products.
Okay. Okay. And then the water part is interesting. I want to go back to that because in your study, you mentioned that 2012 was a drought year in California, but droughts happen throughout the nation, different time, different places. What's your sense? And I know you guys didn't study that part. You didn't do a multi-year like longitudinal study, but what's your sense for the impact of drought? I mean, does California has more water? It produces more food, I'm assuming. Yeah,
and 2012 was also a drought year for the U.S. Corn Belt. So it'll be really interesting to go back and that we have plans to, and we can only look every 5 years because we're restricted to years that have the freight analysis framework data, which comes out every 5 years, the years ending in 2 and 7. So we have it for 2012, and our next step is to go and do this now for 2007 and 2017 and see if our estimates are comparable to 2012. My hypothesis would be that the grain belts will be more prominent in the years that it wasn't experiencing a drought, although food is a bit complex because there is grain storage.
Right.
So it's possible that even though there was a drought occurring, you saw equal amounts of grain moving out of the Corn Belt because it was coming from storage.
Are you able to see waste in that system at all?
No. We don't estimate waste. I know other researchers have gotten in touch and they want to try to estimate waste in the system now.
Well, you've created new questions, right, by putting this out. Yeah, it's neat. I want to go back to water. So in the Central Valley, the farmers are and they post signs, they're very antagonistic towards the system because they need more water. And they're like, water grows food. When you look at, a country that, or at least a state that has a lot of drought potential like California does, do you have a sense for like where the water needs to move, like to reservoirs, to, what are your thoughts and knowledge on that?
Yes, we did a study a couple years ago where we actually looked at California in particular and the drought that happened here 2015 to 2018, and tried to figure out basically what was happening with the water situation, how were farmers using water, and then how is that potentially affecting supply chains or agricultural exports from the Central Valley. And so we saw that basically during that really important drought, there was a lot less rainfall, there was a lot less irrigation available from surface sources, so that basically meant that farmers pumped a lot more groundwater. So groundwater in California is really important to enable farmers to buffer their agricultural production during droughts, so they were able to still produce crops during the drought. And so then what that meant is if you looked at the supply chain, there's a lot more groundwater embedded in the supply chain than you would see in non-drought years. So groundwater basically enables those supply chains to still function.
Right.
And during the drought, actually, farmers were able to fallow less productive lands, and they were able to switch to more valuable crops. So you actually see that yields go up during a drought because you're not growing on the least productive lands, and your water per value of crop actually improves. But groundwater is really important in California during a drought. So that was now during that drought, Governor Jerry Brown at the time implemented the Sustainable Groundwater Management Plan, which I think is being hailed as one of the most landmark water bills in California for the last 50 years or so. And I think that the goal is to basically bring groundwater use to sustainable levels by 2040.
Wow. Okay.
Which is
and then does that
amazing.
Also go with the plan to use reclaimed water in more ways, processing it in more ways?
So the way that works is they've formed groundwater management districts around the Central Valley in California, and each groundwater management district is basically going to have the ability to implement whatever plan they think is most suitable for them to bring their groundwater levels to sustainable limits. So that just means that in the long run, the amount that they're pulling out of the aquifer can't be more than the amount that's going in.
Okay.
So, because groundwater, you can think of it like a bank.
Right.
So if you're, putting in savings, as long as you're putting in money and you're not taking out more than you're spending, you're going to have some savings in your account. But if you're pulling out too much money and spending it, then you're depleting your account. So groundwater is the same. So basically, in the long term, they could do things like artificial recharge, where they're pumping water into the groundwater bank when they have a lot on the surface, so that in the drought year, they'll have groundwater down there to pull out.
Right. It's funny. You just dump water in the ground, and the water just knows where to go, I suppose. Yeah, that's right. So farmers, if you drive up and down the Central Valley, and I keep bringing this up for everybody who lives in France and Germany, it is a giant area for food production. I've noticed that the crops change pretty rapidly. Like the farmer, that's it, no more, whatever. We're planting, in this case, almonds and grapes. Tons of almonds and grapes. How does that impact our water usage and how food moves?
Yeah, it's a good question. So
finally.
So from the farmer perspective, they are able to take a scarce resource like water and create a higher value product, because grapes and almonds are higher value than some of the other field crops, like alfalfa, for example. So from using a scarce resource in the most economically sensible way, that makes sense, but it has the effect of what's known as drought hardening, because nut crops and grapes are perennial crops, which means that basically once you make the investment of planting those crops, they typically last a couple of decades.
Right.
So you don't want to let them die if there is a drought. So if there is a drought, you're basically not going to be able to fallow that land and just kind of wait a couple of years until the drought leaves. You're going to do whatever you can to basically make sure that your crop survives that drought. So you're not going to, it basically removes flexibility in your agricultural system when the next drought comes.
And then what about other things as the market evolves? Like people are drinking less orange juice now, they're eating less corn-based products. How does that impact things? Yeah,
I think farmers definitely are very savvy. They will change their crops to basically optimize their revenue and their profits on the farm, and given their constraints. So I think if it's something that they can grow that's more valuable, then it probably makes sense to switch.
They must hate this keto movement. They're like, damn it.
Keto, yeah.
Eat some grains, would you?
Yeah.
Yeah, because the farmer does have to be smart enough to figure those things out. And maybe they rebrand too. I mean, a lot of times the things we eat are just because they've been marketed well. Mm-hmm. Yeah. What other kind of papers have you written then? I mean, I talked about the water usage. What else have you written that's out there?
Mm-hmm. Yeah, so I've also done a lot of work on global trade.
Okay.
And used some network statistics to try to figure out, you know, some of the key nodes in global trade and figure out if we might be, if the global trade system is resilient or vulnerable to shocks. So that's something that we're interested in. Also, I've been similar to that. I'm interested in understanding if trade or if supply chains lead us to use water more or less efficiently. So I've been trying to use econometric methods to answer that question. So that's, we've been finding that at least on average, globally, trade leads us to use less water, which is encouraging.
And then I saw an article, I think it was today, where they caught fish in London, shipped it to China, and then pushed it back to London. And that seems extremely wasteful, you know, to do that. But that's how that whole product is manufactured. Is that, I mean, on the surface, that seems really wasteful. But maybe, I don't know, maybe you just can't have that kind of a plant in London effectively, you know? I don't know.
Yeah. Yeah, well, that's why doing they call it life cycle assessment or getting the full carbon footprint of a good from throughout the entire production chain is really important. Because sometimes it's surprising, but the transportation carbon emissions are actually dramatically less than some of the production carbon emissions. I remember there's a study a couple of years ago that if British people ate lamb that was locally produced in England, it had a higher carbon footprint than lamb coming from New Zealand. So just because the production of lamb is very low in terms of carbon emissions in New Zealand, and shipping it to London, that fraction of the carbon emissions was a lot lower.
You would never think that was the case. Yeah. So it isn't always farm to market. Sometimes it's way far away to market.
Yeah, well, a lot of times the transportation for food is very efficient. It's things like boats and barges, which are very small carbon emissions per unit per mile traveled. It's not, we're not moving grain on airplanes. Right.
And I guess so one of the things we've learned along the way is that the biggest cargo ships produce a ton of carbon emissions. And I guess that's not the case with food ships, and maybe those guys don't commingle, but those container ships that weigh a bazillion pounds and have all the stuff that we all buy, getting those things to move and then also getting them to stop is the biggest part, where it just puts out tons of carbon. But that's not the case with food as much.
Yeah, I'm not entirely sure. And it could also just be like per amount of food or per unit of food.
Right.
It still is very small. I haven't looked at the shipping part of it, but yeah, the mode of transportation, so moving things on barges and rail in the U.S. is relatively efficient in terms of carbon emissions compared to, if we were to fly, maybe really high quality sushi. We might fly that on a plane, and that then is going to have a much higher carbon emission.
Yeah. What if you could change any, like, one or two aspects in the nation? What would you want to see us do a better job of in terms of water and food and how those things work together?
That's a good question. I think I just really want to make sure that we think about the system and make sure that it's resilient to any sort of disturbance. I'm reading a really good book now called The Taste of War.
Okay.
Which is talking about how, food systems can be vulnerable to, you can think of those as important national security systems, really important for defense. So I just think it's important to make sure that we think of our food system as a security issue, which it's not just an environmental issue, it's a food security issue. And so we need to make sure that our food system is resilient to any sort of disturbance in the future. It could be, military or climate change. Future climate change might change how and where we can grow crops. So food systems might need to adapt to basically reorganize depending on where agriculture is going to be able to occur in the future. So that's also something that I think is really important and want to work on some more.
Yeah, and I'm thinking like, food as a security thing. You, when you raise your hand, you're like, it's really important. There's 500 other micro topics that, not that your topic is small, but there's all these other people that are like, and they're all disparate, and they all need attention. They all need money. It's such an interesting thing. So how does one raise like these issues, like these locks we find out they're maintained, but whatever, let's say you find some other critical node, how do you elevate that message up? I mean, I found you and you said yes, but Congress isn't looking for you right now. I'm assuming, I don't know.
Yeah, no, it's a good point. But I think there is a big consensus that we need to invest in our infrastructure. Mm-hmm. And so I'm not saying anything new. I just want to come up with some methods to help us prioritize that investment so that we can be smart when we do get the funds allocated for infrastructure investment. I hope to be able to say, well, actually, given funds are not infinite, we have finite budgets, where should we most effectively put that money? What are the pieces of infrastructure that, we get the most bang for the buck if we invest in, and where, do we have the biggest need, basically?
Yeah. Where do we have the biggest need? Where do you think we have the biggest need?
That I'd have to do the study.
Typical academic, no answer. But what's your sense? Like if you were going to do a paper, you'd have a hypothesis. Where would you want, if you were trying to solve that problem, what things would you want to examine?
Yeah, my sense would be, probably we have a good sense of where the big ports and the big rail terminals and the big important locks on the waterways are. So yeah, I would guess, we're probably going to want to prioritize some of those locks in the Mississippi. The big international shipping ports, are very critical, very important. Rail terminals, even, Chicago to New York to Colorado. There's a lot of important juncture points for rail. Yeah. Also juncture points between multimodal transportation, between road and rail. So I think also just figuring out what those exactly are. But we have a good sense. It's where, we move a lot of other freight around as well.
These systems, as you know, they stack and they intermingle. And so you're looking at almost like and I'm being unfair, but I'm just going to characterize it as like a slice of a CAT scan. But it's really this whole thing. And you're like, oh my God, this affects it. Because I'm thinking about weather and all these other things. What other kind of systems do you have to look at least secondary, maybe tertiary is too far. But like, what are some of the outside systems you're like, there's no way for me to study this and this, but I didn't know they go together?
That's a good question. So I guess I'm focusing on infrastructure and food systems and water infrastructure. In there, I'm interested in, to some extent, figuring out what policies are really important in shaping that system. Right. And you could also think it could just be because my husband's an economist and he's a finance guy, but I'm also increasingly realizing that finance is a really important element of what goes on in the food system and the agricultural system. So that's a piece that I'm probably not going to touch right now.
Yeah. Well, the bang for the buck, like where can we actually make a difference and most reliably and everything.
Hey, this is Pete A. Turner from Lions Rock Productions. We create podcasts around here. And if you, your brand, or your company want to figure out how to do a podcast, just talk to me. I'll give you the advice on the right gear, the best plan, and show you how to take a podcast that makes sense for you, that's sustainable, that's scalable, and fun. Hit me up at pete@breakitdownshow.com. Let me help. I want to hear about it.
Most reliably and everything. I had a question. I'm going to think of it here in a second. Damn it. Oh, it was good too. It was along those lines. It was the interconnection. You got me thinking about the finance part. You got me distracted.
Yeah.
But these systems they are complex. So finance does matter. And then how we move these things, the products shifting. There's so many different things to wrap your head around. It's incredible. Are you overall like confident with where we're at and how we're progressing towards, resilience and abundance of food and everything? Or are you concerned? And then if you are concerned, is it because you're so into the data that, cause in my world, like all we see is threat and terror. All we see is threat and terror. And you get freaked out. So what's your sense for that?
I'm very optimistic, positive person just generally, but then in the system, we haven't had any major disturbances or food security issues in the U.S. and it's very rare. So I'm pretty optimistic. I think I just want to make sure that we do that we're proactive and that we make sure that something like that can't happen. And just been talking to lots of people. I'm just surprised that there's not really a government agency that thinks about food systems in a comprehensive way. We have government agencies or other agencies that think about lots of other systems in comprehensive ways. So I've just been surprised at sort of the lack of focus on supply chains. There's, focus on just agricultural production,
Right.
but not necessarily the full supply chain. Although I did just go to a meeting in DC last week where they are starting a supply chain caucus in Congress. So I think there's a realization that supply chains are complex and they merit some kind of thinking about them on their own.
Well, and again, taking these multiple systems, I remember my question, and managing them, because one of the things I read a paper on, someone did some great work, and they're like, hey, we need to understand these greenhouse gases, and we've realized that all of our man-made reservoirs are causing even more methane, going into the atmosphere. And the same day I read something about, like, I have the answer for carbon sequestration, it's kelp ladders, and I'm like, I don't think so. Like, it's really hard to, because one decision here affects this part of I have my hand, like people can see my hand, this part of the system. But meanwhile, like this other part, you do have multiple PhDs working and saying, this is the best the system can be, because if we tweak that and we slide that and we add it in here, all of a sudden, we get unwanted results, which, that happens all the time.
Mm-hmm. Yeah. Unintended consequences is a big sort of, buzzword, but, it's true. If you change anything in a complex system, things are going to happen that you couldn't foresee or didn't anticipate, and you just want to try to minimize those.
When it comes to freshwater storage and movement on freshwater and those kind of things. And by the way, it blows me away that we're so fortunate in our country. We have so much fresh water that we use it for going to the bathroom. Mm-hmm. It's like, wow, people would kill for that in other places.
I should say that I also do research in Zambia.
Okay.
So I'm just always, we should definitely really appreciate the amazing infrastructure we have in the U.S. After going there and seeing they basically have no ability to buffer. If they have a drought, they don't have grain storage really.
Yeah.
They have just each household has their own grain storage bin. They don't have much irrigation in case there, is a drought. So the infrastructure moving goods to market they lose basically talk about food waste. There they have serious post-harvest loss, basically getting agricultural crops to market. They lose a lot of that because the roads are really poor. So we definitely have we should appreciate what we have here.
It's bad too. I mean, there's so many. I've been in Afghanistan and Iraq, and you're like, you drive this every day? They're like, well, I fix it every day. And then I drive it, and then I fix it. It's like, oh my God, it's so impossible. The other thing, this is interesting. So we tried to bring drip irrigation to Iraq, right? And what that did, and greenhouses. And what that did was that targeted those farmers as like, you have something, you're in cahoots with the American, or whatever, right? It made them a target. And so bringing the water to them caused a lot of problems. And we were also great at trying to bring fresh water, but never thinking about the system of how do you get rid of wastewater. Mm-hmm. So all this fresh water would be there. Hey, it's a win, except for now you have cholera and all the other problems that come with wastewater that can't be moved effectively. Mm-hmm. It's impossibly complicated.
It is, yeah. Very interesting.
Yeah. So what do you want to do next? Like, what papers are in your head that you're like, I just can't wait to get onto this thing? Obviously the 17 data, but what else?
So many, yeah.
Yeah.
Yeah, I really want to try to figure out, are we optimizing that trade-off between resiliency and efficiency in food supply chains? Mm-hmm. I want to look at all of our food infrastructure as an interconnected system and then figure out, what are the critical nodes that we can prioritize investment in.
Yeah.
I'm also interested in how various policies have impacted or shaped our agricultural decision-making and how that in turn has impacted water.
Yeah.
For example, trade with China, how changes to NAFTA have also impacted agriculture and water use in agriculture. So I'm interested in those trade policies and how that's impacted the system.
Plus, you have the explosion of the Indian and Chinese middle class. And they want fresh fruits and vegetables. They want avocado toast. And how does that impact things as the demand for those things goes up around the world?
Yeah, in China, it's really been soy.
Yeah.
Yeah, they have, as they've gotten wealthier, they've demanded more meat. And so they're importing a lot of soy for their livestock production.
Really? Yeah. And then where do we put our efforts? Is it better if food is a security issue, is it better to focus on Block 52, or is it better to focus on some area where there is conflict and, it's festering and creating problems potentially for allies or even us directly?
Mm-hmm. Yeah, that's a hard question. I don't know if I can answer that.
Okay, I have another question on the food thing. So in terms of, there's the belief, and I'm not saying good or bad, just there's the belief that if we move towards more of a plant-based protein diet, plant-based other things, it apparently takes less water to grow broccoli than it does to get milk out of a cow. What is that true, or are there drawbacks to that system, do you think? Do you even know? I don't know.
Mm-hmm. Yeah, just in terms of the water resources and the carbon footprint of food, it's typically well understood that animal products and animal protein requires more resources than vegetables, just because they're higher up on the food chain,
right.
and they live a lot longer. So if you think about all the grain or all the animal feed that goes into feeding them throughout their lifespan, that just accumulates.
Right.
But there's trade-offs with everything. So by not eating animal products or switching to other products, there's always going to be trade-offs.
And what about the modes of transportation? Obviously, air is not preferred, but rail, trucks, water. What's the best? Can you rank them?
In terms of carbon emissions?
In general, efficiency. Let's just go that route.
Efficiency. Yeah, so I think if you were thinking about the energy or the carbon emissions, that the barge and the rail are known to be the lowest per mile traveled. But I think the road network does increase the resiliency of the system because you have, if you were to think, so when I talk about like a resilient network or a vulnerable network, you can think of the airline transportation system compared to the road transportation system. So the airline transportation system is organized in a way where you have these hubs. So you have major airline hubs like your O'Hare's, your Atlantas, your Dallas, your LA's. Yeah. And so then you have lots of small little airports that kind of feed into these big hubs. Compared to the road system, it's more like a lattice. So you have a more even distribution of cars moving on this transportation network. So in a hub and spoke transportation system like the airlines, if you were to have an outage at one of these hubs, then you kind of widespread disruption. So that's more of a network that's optimizing efficiency, but at the expense of resiliency, compared to a roadway network where it's less efficient because you have just kind of more even spread of cars traveling across the network. But if you have one kind of road that goes out, there's usually lots of alternative pathways, so that's known for being very resilient. So I think the roadway network, even though it might have more carbon emissions per mile traveled, it does increase the resilience in our system. So that's one component it's important to think about. We just had Dr. Stephen Running on the show. He's a climatologist, and I've met him. Yeah, and I just love the heck out of him because he's like, these are the practical things. Let's not do it with fear. Let's figure it out. What is your big concern in terms of if food supply is a security issue? What's the main thing? I mean, is it a given lock? Is it I don't know, what do you think it is? It's a good question. I guess I just want to make sure that we're able to, that we have the infrastructure in place to buffer any kind of increased extremes in the weather from under climate change, or to buffer any, political or economic issues in the future, so that we, because I just think food security and water security are so tightly intertwined that it's important, and it requires a lot of infrastructure, so it requires some kind of long-range planning and investment, and we just have to think about these risks in the future and make sure that we're properly investing in case something does happen.
And then are we pretty good at storing water? I mean, there's so much that comes down to washes. I mean, San Francisco, you don't have a chance. It just goes right down the street and into the ocean. Are we pretty good overall at storing what comes down, or do we need to improve that, you think, over time?
Yeah, we're pretty good at storing water. We have a lot of reservoirs, a lot of dams in this country. And also you can think of groundwater aquifers as a really great way to store water.
Right.
So I think there's been a lot of attention, saying that we should start doing more managed recharge and storing more water underground in groundwater aquifers, which would be great.
Yeah.
And especially in the Central Valley and the High Plains Aquifer, which are huge agricultural breadbaskets and have been depleting their groundwater resources for the last couple of decades now. So I think focusing on, slowing depletion, getting to sustainable limits in those aquifers, because those aquifers I think you can also think of as strategic national assets.
Wow.
That will help us buffer any sort of variability in the future. We can, as long as we have those aquifers to draw on, we'll be able to grow agriculture in those places. So we don't want to deplete them now. We want to have them available for the future. So we're good at storing water. And even if I think about the water footprint of things, you can think of grain storage almost as a way of storing water. Yeah. Because by storing grain, you're storing the water that it took to grow the grain until you consume that grain.
Right. Well, that's interesting. Yeah. I always wonder, when I lived in Illinois, you would see some new hunk of pasture get turned up and stacked up and put houses on it and got all this beautiful black soil. And you're like, oh my God, are we doing the right thing? I mean,
that does make me sad.
Yeah. But maybe, the farmers know, this land's worth more as a house than it is to me, growing corn or whatever it is.
Yeah. It happens around Illinois, around Champaign as well. We have lots of beautiful corn and soy land that gets turned into housing. And I think it's a shame because it's such beautiful, fertile soil, but I know that is going to the most economically valuable use of that land. But but it's still really nice soil.
What question should I have asked you that I haven't asked you?
I think you've done a good job. Usually my interviews are much shorter than this. Usually it's like 10 minutes. So
tell us where the water is.
You've had the chance to be pretty thorough.
Oh, well. Well, that's good. If you don't think of anything, that's fine. It's fascinating to me, and I think it's fascinating to a lot of people. I think you've experienced that as well. It's just, it's neat to have these kind of conversations and explore a topic that we just never think about. The food just shows up. There it is. Safeway, Raley's, Publix, wherever we're at. Presto changeo, corn. Hey, it's June. Where's the corn? Here it is. Yeah,
but in general, I just think it's important to also do outreach like this because I think a lot of people don't realize that professors do research or that people at universities do a lot of research.
I know she didn't say good research.
Maybe not good, maybe bad, but no normative statements, but just that we do research because, if I'm not teaching in the summer, a lot of people will say, oh, are you off for the summer? And I just think it's important for general people to know that professors are doing research, and that's where a lot of our understanding of things comes from, is from universities. So,
and let me echo what you're saying, because we know a lot of PhDs on the show, especially Dr. Rich, who's my research partner, and all you guys do is write and try to publish, either to get tenure or to get these important ideas out of your head. It's all the time. And then you're on a committee, and then you're in charge of, all these other things at the school. You guys get work to the bone. I'm positive you are underpaid. I don't have to even know anything about you to know you work super hard. And plus you're passionate about what you do. You wouldn't get a PhD in something and spend all this time writing it. And the other thing is, I know from writing peer-reviewed papers, is you write the thing and you're like, I just presented this to 20 people.
Yeah, no, that's okay. It's an amazing luxury to be able to work on things that you think are fascinating and interesting and that you're passionate about. So to me, that's a huge perk that, I'm happy to sacrifice some salary for. But but it's more just, I just think it's good to get it out there that
for sure.
The professors do more than just teach. And
they do.
I don't want people to think that we have summers off when we're not teaching.
Yeah, you guys are all working. Every single one of you that I know. Well, listen, thanks for coming on the show. I really appreciate it.
Yeah, thank you. Thanks for the interest.